Hello everybody, we're getting ready to start lesson 4.3 of Algebra 2. This would be part 1 if you want part 2 and part 3. PowerPoints or video, email me here. 4.3, use functions involving E. So we got 34 points here of a skill sheet of classwork. And we got 5 points of notes here for your note-taking guide. Email me for that. And this will be part 1. Here's the standards here for this lesson. Teachers, here's your bell work. Students, this is your warm-up here. The table shows the amount of D that a boat depreciates during each year. T, since it was new, this is your depreciation here. Show that the ratio of depreciation amounts for consecutive years is constant. So show that. And if you need extra room to do this, and you might for this for sure, attach a sheet, students. And if you're an online student, please take a picture of it and send it to me, mail it to me. Okay, our solutions for this bell work. Here's the ratio from year 1 and 2, and the ratio here is constant. The ratio of depreciation remains constant at 0.96 or 96%. And then that was the answer for number 2. If you get the PowerPoint, you can go back and look at that solution. Okay, here's our intro. 4.3, use functions involving E. You studied exponential growth decay. You will study functions involving natural base E. So the history of mathematics, marked by discovery of special numbers such as pi and I, another special number denoted by the letter E. This number is called the natural base, or Euler number, after its discoverer Leonhard Euler. And here it is. The expression 1 plus 1 over n to the nth power approaches z as n increases. Here is a table here that shows how it increases 10 to the 6. When n equals 10 to the 6, it gets closer and closer to e. Okay, students, here's your chance to identify natural base e in your own words. Okay, key concept, natural base C. Natural base C is irrational. It is defined as follows. As n approaches positive infinity, 1 plus 1 over n to the nth power approaches e approximately 2.718281828. So example 1, simplify natural base expressions, simplify the expressions. We're going to simplify this here. So we can use the product of powers property here of exponents, so the e to the 7th, and then 12e to the 4th over 3e to the 3rd power. We use the quotient power of exponents here, quotient property of exponents. It would give us 4 to the e power. And then c here, what do we do with that? Well, we use the power of power properties here. 5 squared, and then e to the negative 3x squared as well, and this gives us this number here. We have a negative 6x here, e to the negative 6x, which will reciprocate. That's the negative exponent property there, and we end up with this number here. Okay, so here's our first guided practice. And students, this one's on you, so do that, students. We're going to do the guided practice now. E to the 7th times e to the 4th. You have the same base here, so we use a product of powers property here of exponents. E to the 7 plus 4 and e to the 11. Okay, example 2. Evaluate the natural base expression. Use calculator to evaluate this expression here. So e to the 4th, how do we do that in a calculator? Second, e to the x4, and we get this number. And then e to the negative 0.09. So how will we do that in a calculator? Second, e to the x, and then negative 0.09 in parentheses. I would put this in parentheses here. And then enter, and you should get this number here. Okay, our next guided practice. 24e to the 8th, 4e to the 5th. How would that calculate? 6e to the 8 minus 5. We're going to use our quotient property of exponents. These will cancel out to 6 here. And then e to the 8 minus 5. 6e to the 3rd, and that comes out to a number. And if you want part 2 and part 3 of this lesson, email me here for that. Worksheets, solution PowerPoints for the skill checks. I got those too. Thank you very much.